Hello everyone and welcome back. This is lesson number 3 for the statics tutorial, and in this video I will cover adding forces by components. First, we'll show you how to get the components for every force and then how you add them so you can determine the resultants, magnitude and direction. Also, how to use the component concept in a way that to satisfy certain requirements. If you have a force, this force is identified by its magnitude and its direction. So, for example, if I have this force F, it has a magnitude, the value F, and it has the direction theta from the horizontal axis, which is x-axis. Now we need to identify the different component, the x component and the y component. This is mainly going to be like perpendicular direction, two perpendicular direction. So we would like to get how we calculate the x component and the y component. And in the x direction, we have a unit vector I to identify the direction and unit vector j for y direction. So now to get the x component of f, we calculate what? So the f of x in the horizontal direction and the f of y in the vertical direction. But as a magnitude, f of x is equal to what? So we always assume the angle theta between the force and the horizontal axis or the x-axis. So if you adopt this methodology, making the angle all with the x-axis, so the f of x will be equal to f cosine theta, and the y component will be f sine theta. But in a different situation, if the angle is theta with the other direction, then you're going to switch. If the angle theta between the y-axis and the f, then you make cosine with the y-axis and sine with the x-axis. So as you can see here, the force is equal to f of x in the I direction plus f of y in the j direction. How you calculate f of x? It is f cosine theta, and fy is f sine theta. Also, if I have the component, if somehow I was given the component, can I reverse the solution and get what is the force f and what is the angle theta? Yes, we can do that. So as a magnitude, the force F is equal to what? F of x square plus F of y square under the square root. So you get Fx square plus Fy square under the square root. And the direction angle theta with the horizontal axis, with the x-axis, it's always equal to what? Tan minus 1, the value f of y divided by the f of x. No matter what the value of f of y, it is negative or positive, or f of x negative or positive, you have to put the right sign so you can get the accurate angle. So now also another situation, not every time you will get the force identified by magnitude and theta angle, but you will be identified by direction, by distance. So in case if we have like the force here 500, it is identified by a distance in the x direction 24, y direction 7. So this way, first if it is 24 and 7, so under the square root you get what? The other dimension will be 25. So to calculate cosine the angle in the x direction is going to be what? The value in the x direction, which is 24 divided by 25. So if you multiply, this is substitute for the cosine of theta, and actually this is actually the cosine theta. Some of the students sometimes what they do is they use the numbers here to calculate the angle theta and then get cosine theta, but it is already given to you. 24 divided by 25 is the cosine, and 7 divided by 25 is what? Is the sine. So this is what it is here. Look at this force here, but this force is what? It has a positive in the x direction but negative in the y direction, and it has 4 for the x component and the 3 for the y component. So now f of x will be what? The 200 multiplied by the cosine theta, which mainly can be represented by what? 4 divided by 5, you get the x component, and the 3 divided by 5 to get the y component. But notice something here. The y component is in the negative direction of the coordinate axis. So when you have it in the negative direction, you make it minus. Again, for the x or y, if the force of the component in the negative direction, you should give it minus sign. Let's move to how to add 3 forces. For example, here I have 3 forces A, B, and C, and I would like to get the resultant of these 3 forces by using what? By the addition of the x and y component, which is the topic for today. So now what you're going to do is, suppose I have these 3 forces, the A plus B plus C acting at a certain point, and I would like to get the resultant of all these 3 forces. What can I replace it with? Just one force, which is the resultant. So there is a steps here. So the first step is what? Is to resolve each force into the 2 components, the x and y component. So for example, to get Rx, the resultant force in the x direction, you get all the summation of all the x component of the 3 forces, and the y, the resultant in the y, the resultant force in the y component of the resultant force will be all the summation of f of all the y component of the 3 forces. Likewise, so now this is what we're going to do. So the first force A will be analyzed into or resolved into 2 components, A of x and A of y. Same thing for the force B, where it has 2 components, Bx and By, and the same thing for the force C is going to have 2 components, Cx and Cy. So now to move to the next step is to do what? So once we have 6 components, now we're going to add all the x component to get Rx, and all the y component to add to get the Ry. But notice something here. The x for the x component, I have Ax and Bx are positive, but Cx is negative. So this is why I put the negative sign here in front of the Cx. But for Ry, for the resultant force component in the y direction, I'm going to also add Ay and Cy. They are positive, but By is negative. This is why we put Ai minus By plus Cy. So this is what I can get the accurate component for the result, the y component of the resultant. Then after that, what we're going to do is, once we get Rx and Ry, so this is Rx, the final Rx and the final Ry, so we're going to draw it, and then get the resultant out of these 2 forces or 2 components. So you get the resultant R, which is making the value, which has the value of the diagonal. So you draw a horizontal line, parallel, and also vertical line here. So you meet at a point, so you connect the point to the origin. So you get the resultant force R, which is making an angle theta. But how to do it analytically? So this is how to do it. To get R is what is the square root of Rx square plus Ry square. And the angle theta, to determine the angle theta, is going to be what? Is going to be what? Tan minus 1, the Ry divided by Rx. And this is how we determine the resultant force using component magnitude and direction. The first example here is I have 3 forces, and these forces are A, B, and C. So the force A has 50 pounds, making 30 degrees with the x-axis. The second force is 30 pounds, making 60 degrees with the x-axis, and the third force C is making is a value of 60 pounds and making 45 degrees with the y-axis. In the analysis, okay, since it's the angle with the x, is going to be the x component for 50 will be in the x direction. The cosine or the cosine component will be in the x direction. The cosine component for the second force will be in the x direction. But for the third force, the angle given with the vertical axis means that the cosine component will be with the y component. Okay, so let's adopt to this methodology. So I have the force A 50 pound, B 30 pound, and C 60 pound. So let's look at the first force 50. So it's making 30 degrees with the x, means it's going to be A cosine 30 will give me the x component of the first force. So it's going to be 50 multiplied by cosine 30, you get the force, the value of the force in the x direction for the first one. Let's do the next one, B. So for the force B, the x component will be also cosine the value in the x direction. So it's going to be B cosine 60. I'm making 60 with the x component, so B cosine 60, you get this value, which is 15 pound. And then the third component is 60 pound, and it's making 45 degrees with the vertical component. So means that the x component will be the sine value. This is why you're going to say, but notice also something here. It is in the negative direction. The x component in the negative direction is going to be negative to the left. So it's going to be a negative minus c sine 45. So when you substitute into the equation, you get the value minus 42 pound. And then all the summation of the x component, you add them to get the Rx. So Rx will be equal to what? All the summation of the x component, so 43.3 plus 15 plus minus 42.43. So you get at the end, I have 15.87 pound. We'll do the same thing for the y component. Whatever cosine here is going to be sine here there. So you repeat the same thing, but instead of cosine here, is going to be in the y component sine 30. Cosine here is going to be what? Sine component in the 60. But notice something also. For the y component for the 30 is in the negative direction. This is why you have to put what? Minus. Okay? And the y component for the C, force is negative. Both x and y are negative. So I have x and y negative for the C component. So I have negative here and negative there. But for B, I have a positive x and negative y. So this is why for B, I have positive x and negative y. Okay. So now you're going to have the B cosine 60. For the y component, going to be minus b sine 60. You get what? In this case, I have 25 pound for the x component of A, minus 25.98 pound for the y component for the B force. So this one, the first one was positive 25, but the next one is negative, and the C is again y component is negative. So when you add these forces together to get the Ry, so the resultant component in the y direction is going to be at the end. You add these three forces, you end up with having what? A negative value. Means what? So it means what? It means when I did the result, the Rx and Ry, so finally is what? The Rx is positive, so Rx is positive, and the Ry is negative, so Ry is negative. So mainly as a result, that will be something like this. And this is the angle with the x-axis. Okay, so this is angle theta. So if you substitute that here, you get the resultant force is going to be at the end 46.22 pound, and the angle theta is minus 69.92. Notice something here. The Ry is negative. You have to put it negative, so it can give you the exact angle. It's going to means that it is minus 60. So this is in the negative direction. The angle here is the negative direction. The angle theta is in the negative direction, and it is what? 69. So this angle will be 69.92. Okay, this will end the first example. Let's move to the next example. Example number 2. Now, in example number 2, what I have here is I have a member AB. This member here, AB, exerts on exerts on member CBD a force F. So there is a force F here coming from this member. So I'm going to assume this is this force. There is a force here, F, coming from this member here. I'm going to call this F. Okay, anyway. So directed along the line AB. So this is F. I'm going to call it FAB. Okay, so it means what? This is FAB. And this FAB is making 30 degrees with the vertical. Okay, now is what is asking for me that, okay, directed along the line AB. If F must have a 280-pound horizontal component, so this force has two components. Let me put the two components of this force. Let me make it like this. Okay, so it has an X component like this and the Y component like this. It say that the X component must have 280. So the X component is equal to 280. Okay, so this is FAB in the X direction, and this is FAB in the Y direction. In the Y direction. Okay, so now let's see what we will get. Okay, so now first, okay, we're going to have these two components. So tell me that the X component of the FAB should be 280. So what's the F component of FABX component? From the equation, let's apply the equation. FAB in this direction. And also we need to get the FABY, the Y component here. Okay, so let's see what is given. What is given? It gives me that FABX is equal to 280. So now let's go to the solution. The force FAB in the X direction, the force FAB, it has two components, one in the X direction and one in the Y direction. The one in the X direction is equal to what? FAB multiplied by, okay, the angle with the vertical, the angle with the vertical axis. So it's going to be what? The X component will be sine. Okay, so FAB sine 30. Okay, now, so I have two equations now. FAB and the X component should be 280. Here is equation 1. And the FABX is equal to what? FAB sine the angle theta. So I have two equations. So 280 should be equal what? The FAB sine 30. So here is the equation. FAB sine 30 should be equal to 280. From here, from this equation, the only unknown is FAB. So FAB should be equal to what? 280 divided by sine 30. So by that, I should be able to get what is the force? What is the force? FAB. So this is the first one. We got FAB. Now, can I get the force in the Y direction? The Y component of the force FAB? Yes, okay. So the Y component, since the angle with the Y component is going to be cosine, so it's going to be FAB. So FAB Y component should be equal to what? FAB multiplied by cosine 30. So you substitute into this equation, so it's going to be what? What we got? 560 multiplied by cosine 30. So you get this value here. So I should be able to get the Y component. Actually, this value is equal to what? What's FAB? 560 multiplied by cosine 30. And this is what you'll get, this value here. Okay, so this will end the second example. So let's move to the third example. In the third example, what do I have? Okay, I have here two forces. One force is vertical, which is 50, and another force is moving this direction to the right, 60 pounds, making 30 degrees with the vertical, the other force here. And then I have a tension cable AC to hold it in a way that, so means that I have a force here acting in this direction in the action in the cable is causing tension in the, so there is a force here from the cable here in this direction. Now before we need to find what the angle. So this is the angle 30, so it's going to be equal to this angle. So the angle 30 here will be equal to the angle here by what? Exchange. So this means that this angle should be 30 degrees. Okay. And what I'm going to do is I'm going to apply a line here. And I'm going to call this is X coordinate and this is what? Y coordinate. So I'm going to put my coordinate axes. The Y coordinate along the line CB and the X axis perpendicular to it. So I have this one is perpendicular to the line here. And if I do this one perpendicular, I have this one is 30 and this one is 30 and this is perpendicular 90 degrees. So what the angle here is going to be another 30 degrees. Okay. So I have 30, 30, 30. Okay. And if this is 75 and this is 30, so again this angle will be 75. And if this is 75 and this is 90 degrees, so this angle will be how much? 15. So now I got all these angles. So now we need to get the component in the X direction. Okay, now to have the resultant force to be directed into the to have the resultant force to be directed into what? Into the length CB means all the X component has to be equal to 0. The summation of the resultant force in the X component should be equal to 0. To achieve that, it's only have the resultant has only direction in this Y, in the Y direction, so means that all the X's will be cancel each other. So based on that, I use this condition to equate to find out what is the tension in CA. So let's do that here. Okay, we say okay, signal force is the resultant force is going to be in CB. So now the perpendicular to it, the value will be 0. There is no 0 value here. So I'm going to say okay, Rx. So this is the resultant force in the Y direction is the complete resultant force. So the resultant force in the X direction, which will be the summation of all the X component, is going to be equal to 0. So I find this one here. This is a condition I'm using now. And the resultant force, the X component, all the three components had X component. So the first one will be what? The 60 multiplied by making an angle 30 degrees with the X axis. So it's going to be 60 cosine theta. And the second force is 50. So 50 multiplied, making 60 degrees because 30 plus 30, 60. So going to be 50 multiplied by cosine 60. And then the tension on the cord CA, in the cable CA, is making an angle 15 with the X axis. So it's going to be cosine, but in the negative sense because it is in the opposite direction of the X. X positive is in this direction. Okay. So now, so we're going to say, okay, minus the tension CA or AC multiplied by cosine 15. So the only unknown I have in this equation, and this should be equal to 0. So this is the equation I have. So the only unknown will be what? TAC. So TAC will be what? Is going to be equal. Put it to the other side and divide by cosine 15. So you'll get the value of the TAC. So finally, we succeeded to get the value of the tension So this is the value of the tension of TAC. So once I get the value in the tension AC, this is the first required. Now we need to find out what is the result. So the resultant, we know that it doesn't have any component in the x direction, so Rx is equal to 0. So the resultant should be equal to what? To Ry, to the resultant component in the y direction. So let's analyze this, get all the summation of the forces in the y direction. This will give me the same thing, the result. And how we're gonna do that? Just to switch the values here. So if I have 60 cosine 30 is going to be 60 sine 30, and cosine here will be sine, so 50 sine 60 instead of 50 cosine 60. And this one is going to be what? Plus, because it's going to be in the positive sense in the y direction, so it's going to be TAC, and instead of cosine it's going to be sine 15. So when you solve this equation, and we know that TAC is already, we determined TAC, which is what? 79.676. You substitute into this equation and you find out what the resultant is total. The resultant is 93, sorry. So I should be able to get the resultant in the direction of CB, and the value is 93.92 pound. And we succeeded also to get the tension and the cable TAC, which is 79.676. Okay, this will end the session for today, and I would like to thank you for watching the video, and please give me your feedback so we can improve or add whatever, put into consideration what we missed or some kind of. I hope you like the video, and if you like the video, please subscribe to the channel, click the bell, and give it a thumb up. Have a wonderful day, and see you soon on the next video. Bye bye, and have a wonderful day. Bye bye.